Hey, what's going on, everybody? How are you doing? Happy Thursday, everybody. Hope you guys are doing super good today. We are finally going to get to ideally finishing out our landing code for our orbital class vehicle. That's the goal for the evening, chat. We'll see what we got to do. I'm thinking that all we really should have to do is take our DCX our subscale test articles landing code, pretty much copy and paste that into a new script, and then we're gonna have to obviously change some things because that vehicle is designed to fly like this, like an airplane, where we're gonna have to learn how to fly like this, like an actual rocket. So yeah, that'll be the biggest change, but yeah, I think that's it. I think that's what we'll work with, chat. How you doing, Graham? How you doing? Hope you're doing well. So if I recall, we left with the test script here. Let me see, Hal. Let me see. Yes, we were testing our actual landing test hover slam. We were targeting the new pad that we put out here, that pad right there. We were testing targeting that. And I feel like we got kind of close with this, but there was definitely some things that need doing. So let's go ahead and figure out exactly what we need. I think I want to go to F9, quick save, load, and that should put us right where we need to be for testing. I want to remember where we left off here last week, because we were working with this code. Did you see my thing in Discord where I told you a couple of things I noticed while watching your stream? Yes, I did, Graham. I think I did. Fairly certain I did, unless you did other things. You know what? I can just check it right now. That's probably the easiest thing to do. In the meantime, let's go ahead and run this code to see what works and what doesn't. Okay, stand by. It's connecting. Uh-oh. Game is frozen, chat. There it goes. There we go. Now we're getting it. The discords. And in the meantime, we'll go pitch and yaw here. And that should be all that we need to do. Yo, Super Sonic Retro Propulsion coming in with that tier 1 sub for 4 Kerbal years of support. Starting us off on a very good note. What's up, Supersonic? SSRP, hope you're doing well. Let me see, Graham. Did I catch what you had said? I think there's a fix to go a bit further downrange with the second stage, also booster right here. You need to overshoot just a tad. Ah, yes. I have thought about doing that, actually, which is to put an offset. Yeah, I have thought about doing that, to put an offset on our designated landing zone. So right now it looks like the vehicle is tracking the pad, looking pretty good. We'll see just how well it can. We are currently about 1 kilometer downrange, tracking 75, 76, 78, 80 meters per second towards the pad. We're almost right on top of it. We're going to overshoot, that's for sure. Yeah, we're going to overshoot by a good amount unless it can turn around fast enough. It's not doing too bad. All right, we're about 300 meters off the center location of the pad. Not bad. Not bad, chat. It's coming in. I fear that the gains may not be optimal though, because it is still going way too fast. We're right over and it's still not correcting. Oh, there we go. Okay, maybe it's doing something here. I mean, it's close. It's close. It's got to do better, though. All right, I'll check that out in a second, Graham. Hey, what's up, Gunslinger? How are you? Yeah, as you can tell, chat, the gains for this vehicle, not tuned whatsoever. Also, it looks like we're going to run out of fuel before this thing actually even gets on the ground. Although it is cruising at a nice 4 meters per second downward. No, closer to 10 actually. It's not bad. But we're going to run out of fuel here, and we're going to drop from quite the height, chat. There it goes! Ah, you didn't even get to hear it, chat. You didn't even get to hear the explosion. I had it muted. Apologies. There you go. You got an explosion. Yeah, bang! Exactly. That'll be your sound effect. All right, well, we broke the landing gear. This vehicle would have absolutely destroyed the tank structure. It would have crumpled under its own impact loads. Yeah, this is a write-off, chat. It's a write-off. It did survive, but in reality, this thing would be completely not intact at all. Like, no. But anyways, not bad. So that's what I want to fix here today, chat, is let's get this right there. This right here. Not so much here and not so much here, but right there would be great. That's what I want to do. We'll see. So first things first, chat. This is the code that we were working with, and we need to basically revamp it to be more in line with this vehicle. The big things are, of course, going to be our gains that we're going to now have to tune for this particular vehicle. Although they seemed kind of okay right off the bat, if I'm being honest, but definitely need some tuning for sure. Let's also go ahead and start working towards a Minerva landing. I was working with a Minerva landing earlier off stream to see how well it would take this code, and it's not very good, so we'll have to basically redo it from fresh. You can at least salvage it for scrap. That is true. Let's see here. So drag force equals area, yeah, 1/2 drag area density velocity squared. Wait, so that's the drag coefficient, right? Yeah. So the thing that sucks, Graham, is that area is variable. That's the thing that sucks, is that area is variable, right? Because the area changes with your angle of attack depending on the shape of your vehicle. So, for example, paint, flashbang. Go here, go there, boom. So if we had the shape of our DCX vehicle, for example, right, which is kind of like this wedge shape, if we were going straight up, let's actually put the arrow backwards, right? Because this is going to be our air, essentially. Our atmosphere, whatever you want to call it. Drag, the force of drag, whatever you want to call this, right? Air. Our drag area is essentially going to be, you know, a cone. It's actually going to be a circle around the widest part of our spacecraft. And that's going to be our area, right? So this is fairly easy to figure out. But you can imagine that as soon as we change our angle of attack, where our air is still coming in this way, but and so our velocity is in that direction, right? We now have an area that's more like this. And so now that's our area. So unfortunately in the game, in order to get our coefficient, like our coefficient of drag never changes, right? But what we actually care about when we're doing our drag force calculations is going to be 1/2 rho v infinity squared CD times A, right? So we actually need the CD times A, and the game apparently does in fact calculate this. It calculates CD times A, but apparently KRPC doesn't have access to this variable. So this is the one that we actually care about, CD times A. And even if we can get an instantaneous, even if we can get our drag coefficient, our area is going to change, which is a pain. Because, I mean, we can't, the thing that sucks about having a drag area that is variable, like you would think like, oh, you know, it's just a wedge shape. You can easily figure out based on angles and whatnot. And that's probably true to some degree, even in KSP, but unfortunately, our vehicle in the game isn't this. This is what it would be in real life, right? Like a solid, single, multi, structural system. But in reality, the way KSP calculates drag and drag area is that, yeah, this is the general shape of our craft, but we have a tank structure here, a tank structure here, we have things in the nose, we have things in the base, we have our engines, and each one of these things has its own area. And all of these have to be, I guess, summed together to give you what the game calculates as CD times A. And we don't have access to that. So even if we could find CD, our area is like, I don't even know how you can calculate that. Oh my God, EJ coming in with a raid. What is going on, EJ? How are you doing, my friend? Welcome everybody into a little paint diagram. Yeah, we'll brainstorm. Definitely. Yeah, we were talking about how do you calculate the force of drag in simulation within KSP when we don't have access to this right here, right? Because for any of you guys coming in, the force of drag, right, is going to be equivalent to 1/2 rho v infinity squared. This is velocity times our drag coefficient times our area. This is constant. This can be known. This can be known. This is our density, our air density. But we don't have access to our area. And the way the game calculates area is that you might have a rocket ship in real life that looks like this. But unfortunately, the way KSP works is that you have a bunch of parts. Every single part on your vehicle, engines, tanks, all of your crew capsules, your reaction wheels, whatever, have their own area, and that all gets summed into here. So I have no idea how we can estimate the force of drag in our estimator, which is basically taking our vehicle's instantaneous point in space and propagating that forward all the way throughout its flight. I don't know how to do that because we don't have access to this, and we don't have access to this. You would in real life, because you would have like a solid system. So yeah, that's the conundrum that we're kind of exploring right now. But anyways, chat, welcome back. Name is Rocket Guy. We are working on automating this vehicle, which, as you can see, failed its first attempt. That's why we got to rewrite our code. We were using an old code that was actually optimized for a different vehicle. We were just testing to see how it would work on this vehicle, and it survived, and we landed 500 meters away from the pad. But we can do better, chat. We can do so much better, especially when our DCX vehicle landed on the pad about 10 meters away. Now it's time to do it. Now it's time to do that same thing, but with this. So let's see what we can do, chat. So let's open up our Python code and get to work. So first things first, I am just going to probably copy and paste all of this code, the stuff from our old vehicle for the most part. We're gonna need compute line of sight angle. No, we're gonna need the corrected line of sight angle. Don't need the rate calculation for this. Let's go ahead and go here. Also, let's just go ahead and copy everything that this one already uses. There we go. Import all of our packages. That's the wrong code. So we're gonna need corrected compute line of sight angle. We're gonna also need our compass heading calculations. We are going to need our normalize angle. We're going to need our Haversine formula and the compute heading error. Let us get all of those first and foremost. Arian 5-4 moment. You have no idea. First thing we ran was this thing was doing a lawn dart because the code was saying, hey, point your vector this way when it should have been 180 degrees. Anyway, not important. Truly an Arian 5 moment. Just 180 degrees is, you know, that's the difference between your rocket going up and lawn darting. Not great. Let's go ahead and also copy this code. This is going to tell our vehicle what we are looking to target. Also, let's make sure that we go. That is not it. Stop it. There we go. Vessel name. So we're going to need that as well from here. Initialize. We're gonna have to copy and paste that over. Yep, we're gonna need that somewhere. Wait, do I need that somewhere? I do need that somewhere. Let's just put that up at the top. Yo, Nova gifting a sub to EJ. There you go. Proton moment indeed. Yeah, 100%. That's right. That is the proton moment. Yep, we had that. 180 degrees off, not important at all. Nah, not even a little bit. Nah, it's fine. It's fine. But yeah, Nova, thank you very much for the gifted tier 1 sub to EJ. Starting the stream off on a very positive note. So it's this one that I care about. We need con vessel sonar airing. That needs to go at the top here. Boom. Like that. Perfect. All right, so from there we have our landing. We have our reference frame needs to get in here as well. Like I said, it's going to be a hodgepodge of a couple of codes that we have here, which I would like to think will speed things along since we've already developed most of it. It's just taking bits and pieces from here and there. Let's move that to the side because I don't think we need anything else from test. I do want starting fuel. Yeah, we're going to have to use that. That is going to go over here under this point. We're also going to need nothing from here until here. Yes, great, grand, wonderful. And then we're going to drag it all the way down and take everything from there. And that gives us a good start, chat. That gives us a good start. So let's see here. That is not what I wanted to do. By the way, EJ, how was Satisfactory today? I saw you were playing it. I couldn't join during the work day. How's that going? You haven't played that in a hot minute. Let's see, 8,000. Oh yeah, we do not need that. God, we're gonna have to delete a lot of stuff here, but that's fine. That's fine, chat. Totally okay. I'm getting there. Pillar is coming along. Beautiful. Beautiful. We don't need any of that because we're not going to be hovering. The ideal scenario does not have us hovering, so let's go ahead and take that. That's going to move everything to mode 1. This is then going to be mode 2. Mode 2, mode 3 is going to become mode 2, and vice versa, all the way down, propagating up, 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 like so. Turn everything off. That's going to become mode 4, which is going to be our landing mode. Mode 4. Okay. I hope I didn't forget anything. Probably did. We'll figure that out during testing. Quick question. I'm here for it. Ask away. Let's see here. That looks all fine. So as you tilt, do you think area is linear? Typically, no. Typically, area is not linear. Right? Because if we're talking about like a conic section, for example, it's all by your radius squared. So that's not linear, right? That's exponential by squared term. Okay, what else do we not need here, chat? You know what? I think I'm going to move our liquid fuel calculation here down to right before we start working with this here. There we go. Thrusters, RCS would be great to turn that mode. Yep, that would be good to have. Get rid of all of this stuff that's commented out, clean everything up a little bit. I'll leave those there in case I want to target different landing zones. Hey Kazlo, what's up, my friend? You get a chance to check out Slim Optimization Refactored? Yes, I did, and I need time to debug because for whatever reason, trying to use Docker, I've never used Docker on this particular computer, and when I tried to work through it, it said that I have a WSL error, and so it will not connect through Docker. So I either need to figure out what's wrong with Docker or go through what's the other one? So yes, I have checked it out. It does not work for me at the moment. So I need to do some debugging on that end. The other thing I actually wanted to ask you, Kazlo, is what version of Python are you using? Because I'm using 3.8, but I saw in your system that you were declaring use of Pi 3.12, but when I do that, KRPC no longer works for me. So I'm sure still trying to also figure out dependencies like that. Yeah, no worries, Kazlo, no worries. No worries. I might just go through the other, what was the other system that you could use, that you had set up as well? 3.12 works fine for you. Interesting. I wonder, because I set up a new environment. I installed KRPC using pip install or whatever. And then, yeah, I go to run my code and it says it has issues for some reason. Podman, yeah. Oh, for Linux, gotcha. Interesting, okay. Well, we'll see. We'll have to see. We'll have to see if it's going to be a Linux versus Windows problem, which it could very well be. But anyways, I did check it out. I just need some time to debug to see if I can get it to work. All right, talim.surface greater than 8,000. We don't need any of this code, actually. Actually, you know what? I want this. I want us always to try and be wings level, I think. So maybe that's what we can do at the very front. If we can always try to be wings level, might be good. And then the other thing that I need to bring over from this code here is, you know what? Let's just take both of these things from this other code. And I'm gonna put them right here, boom. So yeah, we need to engage the autopilot. That's definitely key. What's up, Killmeister, how are you? I tuned into EJ to get a break from coding in Satisfactory, and now back to Rocket Guy coding for KSP. That's right. Welcome, Killmeister. You cannot escape it, okay? You can't escape it. What's up, Terrace? How are you doing? And Ubernator as well. What are you using for input? For which part, Siddhartha? If you're talking about the code that another viewer who's in Twitch chat made for me, he's using integrating Grafana for telemetry visualizations. Yeah. So I gotta do some debugging on that end, because for whatever reason it does not want to work for me. Shocker. Works for one, but not for thee. So doing some research here, the area perpendicular to airflow will be pi times the diameter squared divided by 4. Yeah, that's pi r squared. Then you can use that with the cosine of theta. Yeah, but that's again assuming that it's a conic section, and I don't know how the game actually calculates it, right? Because we were going when we were looking at paint, flashbang out. Right, when we were looking earlier, as I was saying, like, yeah, that would work perfectly if we had a true conic section for our vehicle, because then, yeah, you could just take your area here, and this is your area. It's area equals pi r squared, and then if our area changes with respect to some sort of off angle, then yeah, that's very easy to calculate. But how KSP works is that, yeah, this might be your general shape, but each shape we have tank structures on either side. We have a whole bunch of parts in the nose that have everything. We have different tank structures in the middle. I think we have a crew compartment on the side, right? Everything is like clipped in, to make that body shape. We have engines, and so each one of these has a different area, and I think each one of these parts has an area, which we would then have to figure out the area based on each one of their canted angles off of the vehicle's angle, and then take the vehicle's angle, and you know what I mean? Like, we'd have to sum up the area of each part that's going into the drag equation, and that just seems gross. That just seems like not fun or worth it. That just seems like nah, I'm good. But anyways, we'll just have to see. Okay, so I'm gonna keep the gains all the same. I'm pretty sure the gains are gonna be wrong because these are all the gains optimized for our other vehicle, but we'll go with that and figure things out from there. Anywho, chat. So we should have our cascading controller set up for pad targeting. That should all be fine. We're going wings level. We now need to figure out how all of this is going to get calculated for directing our vehicle to the pad. So first and foremost, we have mode 1, which is going to be our pad tracking code. What's easy is we do not need any of this. If telemetry, so if our horizontal velocity is greater than 50, yeah, no, we don't need any of that. We're always going to be tracking our angle, which is going to be pitch input. Good. Roll control implementation, we actually don't even use it, so I'm just going to delete that for now. We might actually go into, so the whole point behind this roll control implementation is ideally, in a perfect world, if we try to maintain wings level, then all that we have to do, right, is then use our control surfaces to put input yaw and input pitch, and then the vehicle will try to always keep wings level. In reality, which might actually be better for more accuracy is that, like for an airplane, for example, for an autopilot for an airplane. Gosh, you know, I should really just stop exiting out of paint, so that way you guys don't get flashbanged every time. So if we have, for example, an airplane, right? Typically, when you want to do a turn, yes, not only do you do a rudder in order to actually turn the vehicle, but also most autopilots, or at least some autopilots, to try and actually make the, especially for airliners, to try and make it a little bit more comfortable for the passengers, so you're not just like side slipping into your turn, will actually have your vehicle, right, with the tail and everything, if you're trying to turn this way, it will actually roll into it. So as you input rudder, you also, oops, should have done it more like this. You will also input a roll into your system as well. So as you yaw, you are rolling into the turn. So we can also do that as well in our code. That's what this was. We calculate our current heading, we get our heading error, and then we roll with respect to that heading error by a certain amount of degrees. But I want to save that, so I don't want to complicate this too much, because then we're coupling our roll control, our pitch control, and our yaw control. So let's just have our pitch and yaw control coupled and remove the roll input for now, and see how it flies. But generally speaking, I think it'd be a good idea to input this. Hey, what's up, SpaceX fan? How are you doing? This is too complex for you? No worries. We'll get to the flying part here pretty soon, actually. But I think this is going pretty well. We don't need any brakes, so we can go ahead and get rid of that part of the code. That all looks fine. We're in mode 2 currently. So that needs to be mode 1, because we're not in mode 2. Yeah, I forgot to update that part. Okay. So I think that seems pretty good. The other thing that I might want to do, chat, is do 90 plus. 90 plus. Because if I just have my pitch inputs without the 90 plus, then our pitch, our vehicle's going to want to fly like an airplane. But if I say our target pitch is actually 90, it's going to be vertical, and then it will basically fly itself like this, so going backwards. So yeah, that should be appropriate for this part, I think. It's a shame they basically canceled development on KSP 2. Yes, it is definitely a shame. Yes, it most certainly is. So we have this part correct, I think. Target roll, yeah, I guess we'll leave float nan for now. Basically, float nan is the KRPC way of saying, hey, we don't care about having a target roll. It's basically turning this off. So we won't be controlling our roll anymore. We'll see. That might still need to be 0, but we'll figure that out, I guess. If burn flag is true and telemetry, you know what? Let's back that down to 50. Well, no, actually no, because this is going to be the difference between us pointing towards and pointing away, I think. So that should be okay. So that should be fine. What we don't necessarily care about is this stuff. Yeah, what we don't necessarily care about is this stuff. So let me scroll through here for our old code and see what I did for this. We have our current heading. We have all of that correct. We're in mode 2 now. So burn flag should be false. That should be fine. That should still be fine, I think. We're going to want to change. Actually, no, that should be fine. So this is our time to burn, basically saying it's a way to calculate how close we are to requiring our hover slam start. So we're basically trying to say, hey, start your hover slam slightly sooner before you actually need to. That way you don't slam into the ground. So that actually seems good. That seems fine. Yeah, very nice. Let's actually increase this a little bit. We're going to do 0.6 here, and let's actually decrease this a little bit to 0.8. Can't remember if a higher or lower number is faster. I think a higher number is faster, but we'll see. We'll see if we have to change those values. Surface velocity on telemetry. Yeah, I'm pretty sure burn flag is true. That all seems good there. And then if lim, yeah, that should all be fine. All right, again, we'll have to see if the gains are okay for this. Probably not, though. Probably not. All right, that all seems fine. I'm not going to touch any of this. I just want to test it and see how it goes. Yeah, seems fine. Now, I'm sure our gains here are going to need to be tuned because I highly doubt that these are okay. We're never going to even reach that, so that's probably fine. Horizontal velocity controller. Let's actually bring that down some, and we'll keep... because this thing's going to have a lot of controllability. So let's go 60, negative 60, positive 60. I might even want to back this all down as well. I don't know how fast we want our horizontal velocity to run. Because if we, increase it too high, it's going to do this. It's going to want to go back and forth when it's like right over the pad. So probably going to figure out what we need to do there. But I think with that, chat, let's run it and see what breaks. Because I'm sure something is going to have to break. Like this, in fact, actually. Let's run it back. Don't know if it matters in KSP. In aircraft, we don't use rudder that much during turns. Just roll the horizontal component of lift as it changes from vertical. Yep, of course. We use rudder to keep it coordinated so we don't feel side motions. Yes, indeed. Yeah, in KSP, it doesn't necessarily matter for rockets, except I think it might matter for this one, because if we just kept the wings level, where the vehicle was just constantly trying to fly like this, we used the control surfaces in the back to basically steer yaw and steer pitch, so that we were always orienting ourselves towards the pad. So I think if we don't actually turn into what we actually require, it's just going to side slip and cause, I think, issues. We'll see. We'll see. It might be fine. Might be totally fine. Let's go ahead and start up the code. And something already broke. So good. Great. Brilliant. What do we do? Oh, name DCX. Yeah. Name DCX. It's because this is taken from the other code. Don't need that at all. Yes. So this right here, don't care. Just use the clock rate itself. Use the clock rate itself. Use the clock rate itself. Anything else? Nope. Okay. Let's bring it back. Hey, there we go. And how much room do I need for this? Something like that. Cool. And let's go ahead and bring this up to pitch and yaw. We'll leave roll control off, I think. All right, there we go. So that worries me a little bit. I actually think I need a negative sign for it to turn around, but I'll leave it for now and see. What's the moment of inertia? We can get that, but I don't know I definitely don't know off the top of my head. I feel like the docs definitely say you can get the moment of inertia somewhere. Maybe from vessel. Yep, moment of inertia. So we can, in fact, get the moment of inertia, just so you know. And the inertial tensor as well. It worries me that we're pointing away from the pad. Not gonna lie, I feel like this is definitely going to cause us problems. I feel like I need a negative sign somewhere. Did I miss a negative sign? Did I? Oh, I did. I did miss a negative sign. So there you go. You miss a negative sign and that happens, chat. It's actually not technically a negative sign. It's just our heading calculation. It's this right here. I'm pretty sure I want to take it, add it to our compass heading, which is here, right? Yes. So I basically want to take this right here, cut that, and then I think we can delete this, if I'm not mistaken. Can't I delete that? What did I do here? Yeah, I can. I can just delete that. That's what I was actually thinking about doing earlier, and I should have just gone with my gut. All right, landing burn start has begun. So we're in our hover slam. That looks nice. Oh, I may have switched over too early, chat. Hey, soft water landing. Uh-oh. This is fine. Yeah, this is how you get back to shore, by the way, chat, if you didn't know, right? So yeah, we're just gonna fly this back to shore. That's what we're gonna do. Always check your sign to the pad. Yeah, 100%. You've been too positive. Yeah, I should have been more negative indeed. Yeah, now it's just it's a speedboat, chat. Easy. Easy mode. Running out of fuel, running out of fuel. It's a rocket boat, 100%. And there we go. Only 8 kilometers from the pad, chat. How about that? Come on, the shipping industry was already destroying it. Yeah, no kidding. All right, let's go ahead and take that back. Revert. No regrets, chat. No regrets whatsoever. All right, so I'm pretty sure I can delete that part that I had. In fact, I'm pretty sure I can, so I will. So essentially, I want to take this, cut that, delete all of that. Wait, which mode am I in? Oh, I'm in mode 2. Aha, I'm in the wrong one. Let me actually not do that yet. Current heading, that's fine. It's this one. Heading. Yeah. So I actually want this, because we're going to just flip ourselves around 180 degrees because we're flying backwards. So we need to account for that. So we're going to say heading. Actually move this. I should have moved this up here. Heading is going to be heading plus equals 180. And then if we're greater than 360, turn us around. Boom. Go. How does that work? Is that better? Oh, I think that's now going the right way. Yeah. Hey, all right, we're going the right way now. Awesome. Self-retrieving rocket. Yeah, that's what we're working on. We'll see. Largest jet boat on the record. It's a pretty cool title to have, if you ask me. All right, there we go, chat. We're locked in. So now what this should be doing is tracking the pad right there and trying to stay wings level and basically just using pitch and using yaw to track the pad. So we'll see. It's at least going in the right direction. That's a positive for sure. Definitely a positive. Looks like a gain error. Not a gain error. It just looks like the gain's not tuned very well. What do you exactly need the drag coefficient for? We don't need the drag coefficient. We need the drag coefficient times the drag area. Yeah, this is definitely potentially a problem with gains, hence the oscillations and the slow reaction. Because we have in our DCX code an integrator that tries to estimate the overall trajectory of the vehicle, and you need drag in order to do that when it's coasting. 6.6 meters from the pad, chat. I mean, for just running the code for the first time after fixing it, I'm pretty happy. Now, I wonder if that's repeatable, though. That's the question, chat. Is it repeatable? I don't know. But we're on the pad. We are definitely on the pad. It could definitely be a little bit better, because ideally, in a perfect world, right, we are, you know, coming straight over the top of it, and we don't have to get into our hover and come back to it, because that just wastes more fuel. Also, speaking of fuel, we need this to be different. Let's actually change that to be like 12%, because we're already coming back very low on fuel. There's an old saying from my Smash days that applies here. We take those. We do take those. Yeah. That's I'm pretty happy with that. Yeah. 1 meter per second of fuel remaining. No doubt. Actually, how's it even calculating 1 meter per second? We have no fuel. There is 0.00. So where is the extra fuel coming from? I think it's lying to us, chat. Let me see. If I turn on RCS, do we see any RCS puff? No, there's none. There's no liar. It's a rounding error. The fumes, yeah, it's the fumes, 100%. Yeah, enough in the lines, but yeah, zero anything. It's a fluke. It is definitely a fluke, yeah. What is the plan for tonight? Sleazy, you're looking at it. We're trying to take everything that we learned from our DCX vehicle testing and applying it to this orbital class vehicle. Because if we can do that reliably, we're getting back into mission mode with this, so we can have reusable vehicles in our save. That's the goal. I may have pooped my pants a little bit, but that was good. Yeah, yeah, indeed. Okay. I mean, yeah, that was pretty great. That was good. Let's see if it's repeatable. I doubt it's repeatable, but we'll see. We'll see, chat. Dumb luck, yeah. Yes, indeed. If you do have your drag coefficient and every other variable, you can easily just swap it out and get area. So we're trying to find our drag force, but in order to do that, we need CD times A. So we have 3 unknowns, technically. 3 unknowns. All right, let's run it back. Hit the go button, chat. Hit the go button. We want this, pitch and yaw. There we go. Unsolvable, yeah, exactly. Because see, I'll show you, like, what's frustrating, right? Oh, null reference error. That's great. Brilliant. Not cheats. I want physics. Arrow GUI data. See, this is what we want right here. CD times S. And we have it in the game. Which is, I hate that. I hate that we have this in the game, and yet we can't pull it from our code. And I don't know why we can't pull it from our code, because the game has it. But there is no API call for CD times A that at least I have found in the KRPC documents. Because if we had this, then yeah, we could essentially estimate through every point in our flight profile our drag force reliably. Right now, we basically flew our vehicle many times to get an average, and we just use that average, which gets us pretty close, you know, plus or minus a couple percentage points. But yeah, it's not, it could be better, right? Could be better. Can you not have it overcorrect? Yeah, exactly. It'd be nice. Yeah, I think the overcorrection, like what it's doing right now, I think is just tuning the gains a little bit. Because it should never honestly point away from the pad unless we're on the other side of the pad, essentially. So yeah, I think it's just tuning the gains a little bit that's having issues here. And then it goes back and forth. Is it actually commanding to go back and forth? Yeah, you see it. It's commanding to go back and forth because it's trying to track the velocity, but it's overshooting and coming back, and then overshooting and then coming back. So yeah. I wonder if I could just put a rate limit on it. I wonder how bad that would maybe have things happen. Oh, I didn't hit the landing gear fast enough, chat. Gosh dang it. But that was actually kind of repeatable again. We got really close to the pad, so I'm kind of liking this. I'm pretty sure, well, yeah, it would be area. It'd be whatever area your vehicle is seeing drag from. Yeah. All right, let's run that back. But I'm pretty sure this might be good enough to start using it in career mode. Which, if that's the case, I'm all for it. What Starfield mod is this? Unfortunately, not Starfield, Trevor. How you doing? Kerbal Space Program. No mod for that. All right, looking good. And now we're tracking the pad. We're all lined up. So this works, which is great. Great news. Good news, everyone. We have made a flying rocket. 51 kilometers altitude and dropping like a rock. I wonder if it would be worth tuning our gain a little bit. Might be. Certainly might be. What's the word on KSP2? Dead. No. Studio was shut down. Take-Two, the production company, is looking to sell the rights. It's not. Yeah, it's dead. So now we are looking for Kitty Space Agency, which is a real thing, by the way. An independent studio who seems to be doing work on making a Kerbal Space Program-like game called Kitty Space Agency, or Kitty Space Program. KSA? Yeah, KSA, not KS. Yeah, Kitty Space Agency. Yeah, KSP2's dead, unfortunately. It's been dead since what, summer, I guess, technically. Kind of in limbo, and then yeah, it's basically dead. Yeah, see these oscillations? I don't like it. And is that just because of the controller commanding? Yeah, you see this? Controller's going back and forth because it's trying to, yeah, it's overshooting by like a lot, which is not great. We don't want that. So we could definitely tune the horizontal velocity component a little bit to eliminate those. I wonder if it would also help if I controlled the authority limiter. Nah, I think just the gain. The gain should probably be first and foremost what's tuned. Get surface area? That's interesting. Are you gonna stop? Okay, there we go. Uh-oh. All right, track the pad, please. The booster's going for a walk, chat. And we don't have the, oh, there it goes. Okay, it's just gonna land right here, chat. That was a nice landing, though, if I do say so. It nulled out its velocity and all that. That's pretty good. Pretty happy with that, but yeah, still, it's just, I don't know. I don't know why it doesn't want to just, it's here and then just go that way. Just why are you going this way and taking so long? Just, I don't, just more tuning, I guess, chat. More tuning of the control loop, but not bad, I guess. Yeah, faster, yeah. It almost needs like a damper, like a little bit of derivative control or something. So this is our horizontal velocity controller. This is that controller we were seeing. We have 0.3. We do have a lot of integral action, but I kind of feel like that integral action is required. We might want to just increase our derivative controller to be higher than that. Let's see. Let's see what that does, chat. Does that make it better or does that make it worse? Induce a roll. Yeah, that's the other thing, is we could actually implement the roll control. Let's see what happens, chat. Yeah. So we have roll. So let's not have that. So target role not set. Role inputs, heading error, okay. And then we should, yeah. Let's do that then. Let's do update control. Let's move that up. Bring that down here. And then we'll do vessel, vessel dot autopilot dot target role is going to equal role input. Yeah. And then we have our role controller, which is going to be up here, plus or minus 20 degrees. I almost feel like this needs to be a cascading controller. I think it does, right? Because we're basically trying to use our heading error to determine our role inputs. So I think we need another PID loop here. But we don't have a heading PID, do we? And I don't really want to set up a heading PID loop because we already have heading worked out. So okay, that's probably fine then. We'll leave it at that for now. Calculate our heading error, that goes into our role controller. Okay, that's actually fine. And then, no, that should be fine, okay. And then what's the one that we have here? On the end? That's min and max, and then deadband. Ah, deadband. Let's just not have a deadband, that's fine. Don't really need that. Okay, let's see what happens, chat. Is this? Yeah, good. See what happens. What mod are you using? We're using KRPC, or Kerbal Remote Procedural Call, to communicate between Python and KSP. All right. Is that right? That looks right. Looks like the roll gain is way too high though. It's not rolling back. It looks like the angle is roughly correct, maybe? I guess we'll see. It looked right originally, at least. Yeah, I think that's a gain issue. I think that's too high of a derivative term. We'll see. We'll see. Yeah, too high of a derivative term. Okay. Yeah, way too high of a derivative term. It's not letting it fly. It's like trying to damp it too much. So that's good. Good test. This is going to be worse performing though, I think. All right, we're moving towards the pad though. That's good. Have you ever landed with code before? Yeah, we did it not too long ago, King. And we're about to do it again, I think. There we go, going in for a landing. Not quite on the pad, but nice and easy. Heck of a translation, yeah, no kidding. I have a genuine question. I just don't know if you will know what I'm talking about. You don't have to answer if you don't want to. Well, shoot, I'll let you know. Okay, so that is too high of a gain here. Yeah, let's bring that back down. Actually, maybe that needs to be less. All right, 0.5. I wonder if it's our derivative term that's actually trying to keep it from tracking. Also, you know what? Let's add a rate limit here. Rate limit. Just want to see if that's going to help. Rate limit's going to equal 0.5. That might be too little. Yeah, that might be too small. We'll see. I'm just trying to smooth out the response there, because it is working. Like, it's trying to track the velocity, and if it goes over the intended velocity, then it basically tries to stop by pointing in the other direction, right? Using aerodynamics to slow itself. But it's doing that too much when it's like really, really close to the velocity, the intended target. So we either need a deadband or we need like a rate limit to try and slow down the response. We'll see. There's something to simulate aerodynamic forces on craft at body position velocity. Yes. I feel like I've looked at that before, and there's a reason why we can't use that. Isn't it called like simulate or something like that? Or no? I don't remember where it is. Flight? Simulate aerodynamic force. Oh, it's because it's the total aerodynamic forces. I just want drag. This is giving me lift and drag. The vector between the two, not separately, which kind of sucks. Yeah. How the air, yeah, that's a good question. I feel like is our roll correct or is it opposite? Because it seems like our yaw is trying to go this way and our roll is actually going the other way. I feel like our roll is opposite because of that negative sign. We'll see. Although now it kind of seems to be working, so now I'm confused. Now it seems to actually be working. So maybe it's fine. Look at that. Look at that turning so smoothly, chat. It's like spinning right down on top of it. That rate limit actually seemed to be a really good thing to do. Maybe not. Actually, it's as we're overshooting. It was doing so well, chat. It's close. It's close every time. It's just not pinpoint accurate, yeah. Okay, landing gear down. Where are you going there? What? Where are you going? That's odd. Oh, is it because I know what I did. Because of the rate limit. I see. The rate limit's not the call. Although it did handle better with that smaller derivative term. Yeah. You know what? Let's increase the integral by just a small amount. And let's get rid of the rate limit. Actually, you know what? Before I don't want to change too many things at the same time, right? Let's get rid of the rate limit. Yo, and Nerduino coming in with a raid. What is going on? Nerduino, how are you doing? How are y'all doing, chat? Y'all are just in time to see a attempted landing using Python for fully automated stuff. We'll see how it goes. We're moving up to orbital class rockets now. We've done a bunch of testing on subscale demonstrators, kind of like grasshopper style of systems, but now it's the real deal we're trying to make happen. That rocket looks familiar, doesn't it? Doesn't it? Yes, indeed. Yes, indeed it does. It's a cross between an old like Atlas 1 and New Glenn. Yeah, for sure, 100%. A little bit, tiny little bit Glenny, yeah. New Glenn. What's up, Nerduino? How are you doing? How was your raid, my friend? Hey, what's up, JP? How are you? Any advice for doing all of this in Vizzy in Juno New Origins? I don't know anything about Juno New Origins, unfortunately. I mean, I know I'm familiar with the game, like I know of it, but I don't know. I have no idea of what that game offers, unfortunately. So I do not have a starting point for you, unfortunately. I mean, in general, I think all the same algorithms can work. I'm not familiar with that game, unfortunately. Stream was great. We had a big collab with a few other science folks. Need to get you on the next one. Hey, hell yeah. I'm down. That sounds awesome. That sounds awesome. All right, let us check out. So the vehicle is tracking the pad currently. It's looking pretty good. I feel like the roll control needs to be tuned because it seems to just be maxing out like way too much, but otherwise it's okay. And I still can't tell if it's actually correct or if it's actually backwards, but anyways. Wait, did I forget to, I forgot to, my bad. Yep, that would probably help, chat, if I turned on the control surfaces. Just saying. If I turned on the control surfaces, it would probably be better. Now you see? Huh? Maybe not. 54, we're going 23. That seems okay. We're at 28 meters per second, 44 called. We're looking at like we're aiming for the pad, which is good. Not bad. Not bad. Automated engine start for hover slam burn. Oh. All right, gotta start the hover slam slightly sooner than that. Actually, where are we with the hover slam? This is mode 3, and we're not. Wait, where were we with hover slam? Hover slam. Wait, am I not printing that out? Mode 2. Oh, I'm not even printing it out. That would actually probably be really helpful if we printed out our time to burn calculation. We do it there, but we don't do it here. So we don't need telemetry dot velocity. Let's do TB. Let's do that. Let's run it back, same as last time. And let's actually remember to turn our control surfaces on. That would probably be good, yeah. The slam part was good. Yeah, the slam part was good. Yeah, quite the bonk. I've been doing, going back through to watch all of your streams to try and figure out the math and translate it to Vizzy. Great job with everything. You're been the biggest help so far. Well, I appreciate that, JP. I'm glad it's working out for you. I'm glad this, like I said, I feel like all of the equations and general way of doing things can certainly translate over. It's just a matter of how to translate it over, right? Seems your suicide burn calculator is being too optimistic. Yeah, it does, doesn't it? I agree. Probably that's why I want to print out our time to burn calculation so we can see, because right now we basically tell the controller to always keep the time to burn roughly half a second before it should be like slamming into the ground. So we start our burn and we always try to keep our time to burn half a second of where it, would otherwise be 0. But we might need to tune that a little bit and say, hey, you need to make that like maybe 1 full second before burn. Oh, actually, I'm sorry. It's 0.3. Oh, it's 0.3. Yeah, that might be, yeah, a third of a second. Might be a little low. And we'll have to see how our throttle response correlates to that as well. Otherwise, we're looking good. We're looking good, I think. We'll see how it goes. I'm no rocket surgeon, but I think you should reduce the slam part of the process. I agree, Hogan. 100%, yeah. I concur with that statement. All right, vehicle's still tracking the pad, which is good. There we go. It's locked in. So if it's doing this, it's because 4736, yeah. Trying not to overshoot the velocity, but it's like responding too quickly. So I'm wondering if that is still our derivative term or if it's our, it's actually our proportional term. It's doing good now though, because we're 27 out of 22. And our time to burn calc is at 3 seconds. 1 second, start burn, there we go. Oh yeah, you see that, chat? It can't keep it. Oh yeah, it cannot keep it, chat. Yeah, that's the problem. You see that right there? That value right there being negative means that we have passed our mark to burn before we slam into the ground. So we need to have a faster response on our slam controller. Let's also bring that up to like 0.5, give us a little bit of extra room. Let's also make sure we increase our integral action as well, so that way we, the throttle will continue to increase to make sure we're tracking, and that all will hopefully help. And then for a horizontal velocity controller, again, it was, we were at 18, and it was commanding negative. That seemed pretty smooth. And then it goes to -20 and maxes out. At what point and why does it max out at -20? Oh, because it, I see, okay. I see. Yeah, because it's basically switching modes and there is a discontinuity in that mode switch as well. Okay. Okay. Fair enough. And then it starts immediately coming back down because it's trying to track the, it's basically in its terminal guidance mode, so it's really trying to track the pad pretty aggressively in that terminal mode. What else was it doing? Mode 1, 20, we're at 18, commanding 2. That seems pretty good. There's no big oscillations here. It's actually tracking really nicely. Here's some oscillations, -48 and 27. Yeah, you see that? It goes from -52 commanded all the way to 0. Like, what is that? What are you doing? So what would that be a response to? Because we're at 49 and it's technically, oh, I see why. Oh, okay, no, that's actually fine. It's because we passed the pad. Like, all these numbers right here are our velocity. So we're going 36 meters per second towards the pad. And then all of a sudden we pass the pad and now we're moving away. And so negative means we're moving away from the pad. So that's why it immediately commands a swap. Yeah. Okay. Okay. That makes some sense there. That part doesn't, though. Definitely just gain tuning now, chat. Let's bump that down to 1 to see if it makes it a little bit less aggressive. That might just make it unstable because now we have a proportional and integral that's the same value, and integral can take over and cause things to go wildly unstable, but let's see what happens. Yeah, no Kerbals were injured. That's right, because it's autonomous. No Kerbals were injured indeed. I missed it by that much. You're not wrong. Oh, Hogan. Cute kitty cats, of course. Very nice. All right, let's run it back, see what happens. Oh yeah, and you know what? Actually, before we do that, let's actually change the roll control a little bit. The roll control seems to be a little bit aggressive. So can I bump that down to 1.1 rather on the roll control? And I want to see if that's gonna make any difference in the response. And let's bring this back here. Pitch, yaw, there we go. Yeah, exactly, Code Man. It really shouldn't, which I feel like should be the derivative term, but at the same time, we tested a higher derivative term and it was actually turning away before it even happened, so it was still doing the oscillations. So maybe it's just a mixture of it, I'm not sure. There's also a few quick performance optimizations and calculate landing burn. Oh, is it really? Oh, I need to do a git checkout to a different branch to see what you were talking about. I have to check it out. Actually, can I just look at it here on the GitHubs somewhere? I think I still have it up. Yeah. While that's going in. See what we got here. I want to see, was it in utils? I'll have to find it. Basically, don't calculate G and engine offset on each frame. Ah, that's fair, actually. Good call. Steering, oh, it's in steering logic, thank you. We don't need that, we don't need that. We need steering logic.py. Steering logic.py, open, see changes. Okay, stand by. Hey, look at that, chat, there we go. Much better on the response. Okay, just land. Stop it. Land. Come on. Yes, you're right there. You're right there. Land. Come on, just go down. What are you doing? Nice and easy though. There you go. It does look pretty good. 11.97 meters from the pad. Not bad. Not bad. All right, let me see. Flashbang, chat. I'm sorry, okay? Yeah, flashbang out. You know what? I'll just move it over here so that way you guys don't get flashbanged. Looking at telemetry code. Steering logic. You said you did the updates in the steering logic, is that right? Steering logic.py. Don't need that, don't need that, don't need that. Calculate landing burn. Brilliant! Let's check it out. So steering logic. I am using steering logic, right? To do that calculation burn here. Pretty sure. Just going to make sure. Slam controller dot update and TB. To be or not to be is calculate landing burn. Cool. There we go. So you said calculate landing burn, get flight path angle, R mag V mag, R mag V mag return. You said to give it, you know what, let me just copy and paste. We'll see. Boop. And boop. All right, update that. We get rid of get drag and get flight path angle. Okay. Well, we're not using get drag anyways, so there we go. Very nice, very nice. Calculate landing burn time to just now become, wait, is this old? I just view the file without all of that stuff. There we go. Should have just done that in the first place. So we should have essentially this. And you do get flight path angle, you move, get flight path angle. Okay. Wait, so is that the old one? Calculate landing burn, and this one is calculate landing burn time? Wait, hold the phone. Which one? I'm sorry, let me see what you're saying, Kazlo. Which one are you talking about? I moved get flight path angle outside of calculate landing burn. The function redefinition costs a few tens of milliseconds. Gotcha. That's a W still? 100% that's a W. What's up, shock value? So which one should it be? Because I have multiple, right? Sorry for the flashbang chat. So we have calculate landing burn, which is what we're currently using. Is this what you updated? Because I also see this. That's the same as that. Well, not the same, but you get the picture. And then we also have this one, calculating burn. Then we have this one, calculate landing burn time. So I've been told I need to try Kerbal Space Program. Now I can see what it's all about. There you go. We are doing a little bit more than what the stock game is all about. We are quite literally using code that we've developed to control our rockets. The stock game, if you just wanted to jump in and play the game, you don't have to do that. But yeah, you can build whatever you want, however you want it, and then fly it, however you dream. But yeah, it's been good. It's been good. Speaking of flying it, chat, is that repeatable? That's the question. I like where this is. I think no matter what, so long as we don't lose boosters, I'm good with running this through mission mode. I think that would be great. So we can actually reuse our boosters in the near future. So let's go ahead and save that real quick. Take this, blam. Get flight path. What'd I do? Oh, I changed that. Yeah, let's just run that back real quick until I fix it. And then we'll run the code. There we go. Celeste. Drag tuple times dynamic pressure number is your formula for the drag coefficient. Okay. Gotcha. I will link you here in a second. Yeah, cool. Yeah, if you can put it in like a paste bin, Kazlo, just like what needs to happen, that'd be great. Because then do you make the separate calls like outside of the loop? So like in our main here, like do you move it up here and you calculate, you know, your gravity and whatnot, and then feed that into the thing? I got you. I appreciate it. Kazlo, you're the man. I'm here to cheer and watch Python steer. Hell yeah, names. I like it. Great use of alliteration and rhyme. Ah, okay, cool. Yeah, I see where you're going with it now. Yeah, that makes sense. That makes sense. Although, to be fair, Kazlo, your force, your gravity, your acceleration due to gravity does change with lower altitudes. So, just in case that matters. Actually not doing too bad here, chat. And it is rolling, which is nice. It is tracking the pad. That's it right there. That's where we want to land. This is actually behaving pretty well. I'm not gonna lie. Happy with that. Are we like right over the pad? We're 180 meters from center point. Landing burn is about to start. Slightly off the mark here, chat, but it's trying. Oh, it's trying. I hate how long it takes for it to like come back. I don't know if that's a gain problem or if that's a KRPC problem. As it just goes this way. What are you doing? Oh no, it's gonna flip over now. See, the reason why I'm questioning on whether it's actually a gain issue or a KRPC problem is the KRPC backend. I have noticed, if you look at the heading implementation and whatnot, or the control system in general, is it requires certain things to be in alignment before it moves on to like the next target direction. So for example, if you are trying to control roll, pitch, and yaw, sometimes the autopilot from KRPC, the mod that we're using, it sometimes requires pitch and heading to be aligned before it rolls. Or sometimes it requires pitch and roll to be aligned before it does heading. I've noticed that in several places, and I don't know if that's what's happening there, or if it's actually our gain implementation, if it's actually our PID loop requires more tuning. Because like sometimes, right, we get really, really close, and then sometimes that happens where it like lands and then it doesn't actually move towards the pad until like something clicks, and then all of a sudden it tips over and tries to move, right? So I don't know what's actually happening there. Hey, what's up, Audev? How are you doing? I think maybe gain scheduling is in order. Like the approach is great, but the control needs changing during the last phase. And I have done that actually. So we could try tuning the gain 100%. Yeah. See, this is mode 4, and before entering mode 4, we do change the gains. So I don't know. So it could just be that we need to tune these gains 100%. I mean, this is pretty small actually, now that I'm looking at it. Right? Maybe that's actually what's happening, because we have a big integral action here, and that means that it takes time for the controller to wind up to have our error integrate over time. And we don't actually have a large enough proportional gain to actually make the response click over. So let's actually increase that and see what happens. That might be too much. We'll see. I just want to try and test some things. So we need that one there. And then I have another check up here. There we go. So yeah, let's run that back and see again. Happy it's almost Friday? Yeah, 100%. You should try programming it to start at full throttle. You know, that's actually not a bad idea either. It's actually not a bad idea, yeah. Have we tried rolling towards the pad in mode 3 and 4? I was thinking that it was still doing that. That's also another excellent point, because in mode 3, we're actually setting it to none, so that's fair. We can continue to do that. Are we still doing that in mode 2 even? Mode 2, we're actually not even doing that as well. It's actually not a bad idea. So if we take our roll control implementation and move that down to mode 2. Where are we doing all of that calculation? Here we are. That's calculating our heading, our pitch. We'll now calculate our roll again, and then we'll make this our roll input. Okay. Yeah, it's not a bad idea, actually. Okay. Run it back. We'll see. It accounts for latency in its control system? Yeah, by having like insane predictors and whatnot in it. Because it has so many more sensors available than we have available. It's essentially predicting several states ahead of itself, ahead of its current state, which is pretty cool. But probably uses RTOS. Yeah, having real-time control is very nice. 100%. Okay. Rolling. Coming down almost on top of it. Yep, we're only 100 meters from the center point. All right, controller, move that way, please. There we go. It's doing it, chat. Look at it go. Look at it go. All right, so this is what I was also worried about. We increase our gain too much, and then it's not going to be able to track. It's just going to do spiraling circles as it just constantly overshoots. Yeah. Yeah. It tracked the pad better that time, I think, though, with that change for the roll control. But H velocity controller still needs some work. So that might be too much. Let's just go to 1. Let's double what we had beforehand. It might be okay. Might be better. Yeah. I like it. Okay. Seems good. ARPC looks more difficult than KOS. Probably. Because you're actually using like Python and stuff like that, where KOS I think has a little bit more domain-specific functionality, right? It also just could be me. It just could be how we're implementing things. Let's see here. What was I going to do? That looked okay, all things considering, but see, we were commanding -10. Oh, I know what I wanted to do. In mode 4, it might be good to change this so we're not coming down, we're not landing until our horizontal velocity is 0. Because right now it's like, okay, we enter mode 4, and then no matter what our horizontal velocity is, we're just immediately descending. So maybe we should actually stop our horizontal velocity before we then touch down. Why not add Ferrum into it? Because that's too big. It completely changes the game. I don't want to change the base game too much, which is why I mainly use just utility and visual mods, not like RSO and stuff like that. Ferrum Aerospace adds like complete rework of all the aerodynamics in the game, which is awesome, but also a little bit too involved. So one thing that I wanted to do, I bring this, I think we had our old code. Yeah, there we go. Because we were using something to do just that, chat. In mode 4, if I copy and paste this, I want to see what this does. If we copy and paste this that we had, oops, that's too much. Oop. Into mode 4, what we can do is essentially track different altitudes for when our horizontal speed is greater than 1 and when it's actually less than 1. So there's that. One thing I'm looking forward to from KSP is this pull request, which allows for individual thruster TVC control. That would be amazing. Yeah, that would be amazing. Also, Kazlo, did I miss something from you regarding the hover slam calculation? Per maybe, or maybe not. Just making sure. You played in 6.4 scale for a while because getting into orbit was getting a little too easy. Hey, that's fair. That's 100% fair, yeah. So what we should have now is if our horizontal speed is greater than 1, we are going to try and track an altitude of 10 meters above the ground. Otherwise, we will then start descending. And also, if our speed is greater than 1, we should be trying to null out our velocity. That's what this stuff does here. So I think that's good. I think that could be doable. We shall see, though. We shall see, though. I don't know if we need our target roll to be set here, or even here, because we're essentially just trying to, maneuver to the pad. I don't think we have to roll for that. Things to think about, chat. Things to think about. But yeah, I think our gain for our horizontal velocity was a little too much for that, potentially. Because mode 3 is doing that and slewing to the pad. Let's change this down to say 2. Yeah, let's change that down to 2. Actually, you know what? No, let's leave those gains. And then in mode 3, horizontal velocity, we have this. I already changed that, didn't I? Okay, cool. Because this was at 0.5 and then I changed it to 5. So I think we're good now. Let's run that back and see if it's any better. Ah, okay, Kazlo, gotcha. Oh, thank you for reminding me, Pooner. I'll get that going for you in 1 second. The bot had to update, so let me restart the bot here momentarily, Pooner, and I'll get you the log as soon as it comes up. All right, see what we got. That looks good. Pitch and yaw. There we go. Start that landing mode. Why must you update, bot? Why must you do this? All right, let's track the pad, see how it goes. But like I said, we're consistently on the order of basically landing on that hexagon, which for now I think I'm pretty happy with. But that means that we can like build a vehicle that can go out there and pick this up and like retract it and then wheel it into the VAB. Then we can recover it. That'd be pretty amazing for our hardcore career mode, saving us a lot of monies. Because every little bit of money that we can get means that we can upgrade our facilities that much faster, because our research center currently needs 16.9 million Kerbucks to upgrade to level 3, which is just horrible. Just absolutely horrible. All right. That seems good. Let me get that for you. Does that work? There we go. Perfect. All right. It's moving, chat. It's moving. I like the roll control here, though. I think it's a lot smoother than it was before. It could maybe be a little bit faster in its response, but it's not bad. While I'm thinking about it, let me actually go up here and change that. Just a slightly faster response. Maybe 2.5? Because that was 1 before, so we choked it down pretty far. Yeah, I think if roll control can be a little bit faster, wouldn't be bad. We're consistently right on top. Oh no! Like I said, if we can get something like this every time, I'll be really, really happy. And then it goes into landing mode, chat. Boop. And that was 28 meters away. 28 meters from the dead center line, which, like I said, for now might be good, because I think the only way that we can do better, chat, is if I completely write my own flight controller, which is going to take some time, working with probably quaternions, getting into proportional integral navigation, essentially creating a stability augmentation system that can actually input for the game as if I was controlling WSAD keys and not relying on the autopilot, which is the KRPC backend. So I think that's the only way we can get better. But pretty good. Okay, one more time before I start looking at using this in a mission mode, because what I kind of want to do next, chat, is figuring out, can we build a vehicle that can come out here and pick this up? That's what I would like to do. Because then, like I said, we could recover it. We can for anyone who's new to the stream, this is what we would do in our old save. Purple space program, screenshots. Yeah. So we could build cranes and then pick up the landed booster and then put it back on the pad. I don't know if that would be of interest to you guys. See, we would build payloads and the crane would lift them up and put it back on. We would basically build and stack the entire vehicle on the pad and then launch it, which was a lot of fun for me. I don't know. Again, I don't know if it was fun to watch, but yeah, that was. We could do this. We have the technology, chat. We have the technology. So that's something. So we could build a recovery vehicle to come out here, pick it up, and then we could build the crane, put the crane out here, drive it over to the crane. The crane picks it up, puts it on the pad, stack another second stage on, stack the payload on, and boom, there you go, right? I have made a PR2. Have you now? Let's see here. Blam. KRPC Rocket Avionics. Pull requests. Calculate landing burn time optimizations. What, why, and where? Yeah. Okay. Brilliant. So let's see. And I think all you did right was change calculate landing burn. Get flight path. Oh, you still have 2. I think it's this one because you moved everything out, right? Yeah. Yeah, let's actually look back at the changes here. So steering logic. Yeah, you move that out. And then we are in calculate landing burn time, vessel G engine offset. Aha, I see, okay. Good. And then you do G engine offset and then before. Okay, cool. I still might want to do G because, like I said, technically speaking, G changes as you get closer and closer to the body. That is why. But the engine offset, I 100% agree that we do not have to find the parts, list the parts, find the name with the engine and take the first engine and then offset that. Yeah, we can do that once and that would probably be a huge help in and of itself. Yeah, and then change that. Okay, I like it. Okay, well, let's see. So we have in steering logic our calculate landing burn, and we only have one instance of that. Very good. So let's go ahead and delete. And then let's go into a view, file. And then we need to take, not that one, but we need to do get flight path angle. And take that. Because I already, no, you just move that out, right? And then we can move G back in if we have to. So yeah, let me actually not delete that just yet. So yeah, we'll take these two, copy and paste that over. Brilliant. Yep, we never use mass, so we don't even need the mass. We don't even use the drag scale, so we can get rid of that every time as well. Cool. I will continue to use G for the second, because G does technically change. That goes under surface. We'll put that back. So we don't necessarily need G, but engine offset would be great. And then we take engine offset, take U, do U once at the very beginning here. And then we add that into our calculate burn, engine offset. Yeah, that should help, right? You were printing G and it didn't change. Really? Oh, okay. In that case, fair enough. Could have been a rounding error. Like, how many decimals were you doing? Because I mean, it's definitely not going to change a lot, right? But technically speaking, G does change, or at least it should. At least it should. Because your equatorial radius should change. Vessel.orbit.body, vessel. That's squared, gravitational parameter squared. That's actually, yeah, you're right. The way I'm calculating it is stagnant, right? Because we're getting our gravitational parameter. Actually, no, gravitational parameter should change with respect to distance, and then we're dividing it by, whatever. We'll do it once. It's fine. I could dig it. You're saying it's not changing by much, rounding error or not. We'll do it. That should definitely help it go faster. Anyways, less calculations to have to do, which means go here into G, not F, G. There we go. Okay, well, let's bring it back and see chat. Thank you for putting that PR in. Let's see how it goes. Is it done in other modes? Shouldn't it? Oh, I do do it in other modes. You're right. Yeah. That should be it though. Just in the two modes. The two modes that are tracking the pad to start the burn. Yeah. Okay. Yeah, exactly. Names. Yep, I realize that. That is correct. It is a static calculation. We should be able to actually calculate G based on our distance from the center of the planet as it's changing, which actually might just be what I need to add instead of just using the radius of the planet that we're orbiting. I should actually get the radius of our vessel relative to that. Nice, Kazla. Okay, cool. I trust you. I believe it. Let's see if it certainly helps with the responsiveness. Okay, looking good. And we're rolling. Perfect. We're in alignment. Back in the pad. See, why is it? Do you find that odd still about our pitch? It just wants to like fluctuate really rapidly. I might actually need to put a rate limit on there because it works great here, but just at that point right there, for some reason it has a tendency. Well, that seemed a lot better. Yeah, that seemed to happen way faster, actually. Way smoother, at least, anyways. And then why are you aiming away from the pad? There you go. Should aim towards the pad, please. All right, and go in for a landing. Not bad. Okay. I mean, I'm pretty happy with that, chat, honestly. Okay. Gosh, I just had a silly idea, chat. I just had a silly idea. Do I want to do that? Yes, I really do. I really do want to do that. Okay, Space Center, stand by. Smooth as butter, very melted butter. Yeah, that you were right. Those calculations way bottlenecking. Tower is go for catch. We're not quite at the tower stage, okay? Before we do anything like that, we got to get to drone ship landing, and I'm pretty sure we're still far away from drone ship landings, to be quite frank. Like I said, I think to do that, we have to develop our own actual control system. Just loading. Okay, sure. You love silly ideas? We'll see. We'll see. I mean, if it works, is it really that silly? So, if we go into here, and we scroll down here, and then we look right here. Right? I want to take that off, actually. Thank you. Because then actually, you know what? I should not have done that because I want this to be motor is fine. Damping should be, I think, pretty high. Reverse rate should be fairly okay, and that should be fine. Yeah, I definitely want that motor to be kind of very low though, so it kind of damps it, but otherwise it's not gonna just you know, make it rigid. Why don't you make the pad bigger? Easy fix. Oy vey. Stop. Alrighty then. Great. Grand. Wonderful. Advanced grabbing unit? Wait, what is this? Oh, it's a junior? How long has that been in the game, chat? I am just now learning of this. How long has this part been in the game? I swear I'm just now learning. Oh. Yeah. Brilliant. I swear I didn't know. Take you off. Okay. Here we go. That's fine. Save it. We need some gutsy pilots. That looks good. Quiet. See what goes. See what goes. Yeah, we'll see what goes. Okay, calm down, okay. Why aren't you rotating? I'm scared. I'm scared, chat. Hold me, chat. So why aren't you rotating? Oh. Wait, what? I am confused. One power loss locked. Free. Oh, is it? It's because of these? You know what? I gotta try that. Did I accidentally strut the wrong thing? I may have just accidentally strutted the wrong thing. We'll see, I guess. Huh. Yeah, I got no clue. No clue. Come on, KSP, thank you. But yeah, you're doing that, and then oh! Wait, do I have a part? One of these parts auto-strutted? Not that one. Not that one. Is a part auto-strutted? I'm so confused right now. Why is this not rotating? Plenty of electrical charge, so it's definitely not that. Is it strutted to something that I can't see? Is it this? What is there that's left? Are these just not attached to it or something? What are these attached to? Wait. Do I have one inside of the other? Is that the problem here? Ah! I see, it's this one. On the bottom. Wait, is it because it's attached to that? Oh, this is fine. Just going a little joyride. Is it this one? Trying to figure out what is strutted, or what is auto strutted, or something. Because that should not be. I don't see anything that should be strutting that in. But it does not want to rotate. It really doesn't want to rotate. Not even that one. What is it auto strutted to? I'm so confused. Here, 1 second, chat. Revert display spring hanger. Let me take the thing off, the arm, and see if that's it. From what it's attached to, I don't think that would be it though, because we have that, which is attached to that. So those are not attached to that, which is good. That's a good thing. That is attached to that, so that's good. So those are attached correctly. I think those are fine. Auto strut disabled. And is that able to rotate? Maybe, is it this that's able to rotate? Well, having that turned off probably might help. That's fine. I have no idea. Let me take this off for a second. We'll attach it up here, just so we can keep it. Oh dear. Not sure what's going on with that. If this problem persists, I might have to go to the VAB, because I think we have another version of this in the VAB. Or no, or were we just using A? The elephant. That's right, Hawk. Yes, I give you the elephant. The elefante. We'll see. If not, maybe I'm just using the wrong... Maybe I'm just using the wrong version. Oh, nope, that worked. There we go. That was correct. I changed two things though. I changed this placement. That's so bad. Oh dear. What have we done? The elephant? Oh my god, portable. That's actually too good. That's actually too good. Oh, okay, sure. I guess 0 just isn't possible. All right, well, we're here, chat. I don't think this is going to work because I think this is going to be way too difficult. It needs to actually be under us and not on our nose, or not act as our nose, I guess I should say. But we'll give it an attempt or two. I just want to see, like, does this make sense to do? I don't know that. I'm not convinced that it actually does yet, but. Okay, this is why it cannot be on our nose, chat. That was surprisingly easy. Worked like a charm, chat. Worked like a charm. Oh, I forgot to. Yeah, revert to space bling hanger, please. A Rocket Lab moment? Yeah, I guess it was a Rocket Lab moment. All right, well, you know, at least we tested the thing that we wanted to test. But really, what I'm all about here, chat, is that. And where is our center of mass on this thing? Oh, it's actually right there. Perfect. Okay, well, we'll do that. And that's already there. Perfect. And we're gonna go ahead and save it and launch it. We'll run it back. So yeah, we need it to be on our center of mass. Otherwise, that happens, chat. That's a perfect example as to why helicopters don't pick things up from the nose or the tail or any other place except for on its center of mass line. Yeah. Yeah, it might indeed ought to. It's got issues, you know, but those issues can be normal, I've heard. Alrighty then, let's move this back over there, shall we? Yo, Snackless coming in with a Twitch Prime for 12 Kerbal years. 12 Kerbal years of support. Thank you very much. How are you doing? Oh, I'm controlling from the wrong spot again, as I always do with this craft. There we go. There we go. Boom. and draw it out. We actually, Portable Gym Snackless came up with the Hellephant. Yeah, it's the Hellephant, which is too good. Yes, that was the Hellephant. Just casually moving at 45 meters per second in a big old helicopter, chat. How about that? No, I'm Squidward, yeah. Okay. We're on station, chat. I'm confused by your tactics. I can't tell if it's actually controlling or not, but oh well. Oh yeah, you know what? I should have done alternating chain links. I really should have done that, actually. Oh, it needs to not be at 90, right? It needs to be at 0. I'm so silly, chat. That would probably help. Yeah. That would probably help. Yeah. Okay, there we go. Check DM enable. Okay, I will. That pusher prop design is cool. Thanks, Floating. Yeah, it's a mix between a Sikorsky Sky Crane and a Sikorsky Boeing Defiant, the SB-1 Defiant. So it's able to go pretty dang fast and carry some pretty dang big stuff. I have no idea if it can carry this thing, but we're here to try. Yeah, I really should have given it alternating links. But anyways. Ooh, this is tough. Especially when the autopilot is not good enough to keep it going. Okay, okay, oh! Oh no! Oh, no! Stop! Okay, we're fine. This is fine, chat. This is totally normal. Totally normal here. Totally normal, right? No. Not normal. Not okay. Oh, dear. Okay. Helicopter not strong enough to lift it all the way. Yeah, not strong enough. Well then, that was fun. Just wanted to check that out. That is amazing to hear, Snackless. Congratulations. That's wild. That's pretty wild. I think that means more damper and more helicopters. Yeah, probably, Pico. Probably. But we can shut down the engine, I guess. So there you go. All right. Well, let's just revert that. So that didn't work. Okay, chat. I'm gonna put that out there. That did not work. Go figure. yeah, let's go ahead and reverse. So I guess the thing that we're gonna have to do, chat, if we really want to make this work, make this happen, is change the vehicle design, add a docking port to like the bottom and like the top, and then create like a transporter erector that can come out here, push up the verticating arm, and then do something like that. That's probably what needs to happen, I think. Lift it off the ground, basically make a big version of our DCX transporter, kind of something like that, I think. But that was fun. That was a fun experiment. You need a helicopter. Yeah, just add 2 more rotating rotors. Just add 2 more of them, right? Stack them. That'll do it. That would actually, funny enough, probably actually do it, but nah. Yeah, just a little heavy, a little bit heavy. Yeah, indeed. And too much spring in the way too much spring in these things as well, between the parts, you know? Do you see that thing come apart like that? Yeah, like a big rubber band. Yeah, big quadcopter, exactly, something like that. Anyways, that was just a thought. Like I said, I just wanted to see what would happen. Okay, so what I think I want to do, chat, is let's go to our Minerva vehicle again. Let's actually go to the VAB version. I want our reusable. And let's add, I think, a couple of docking ports here. Yeah, let's add a couple of docking ports here on the back. So we actually have the ability to grapple it. So we'll put one like right there. Cool. And then we'll move one up as well. And put it like right there below the RCS. And then let's make sure they're snapped. Absolute. Okay. Good. And then same with this one. Snap it. Absolute. Perfect. So now those should be completely in a line. Brilliant. And we'll see. We'll see what that does for us. So let's go ahead and save that. Go ahead and swap. Save that. Perfect. Brilliant. Wonderful. And then this, we were testing 10 tons, I think, and it was actually able to do it. Not quite. I think on full reusable mode, it was just short. It was like we can do 9 tons, not 10. But I think I'm going to test this with a little bit less. So that would be, let me confirm that. Where's that other tank that we were just using? This one. So it's 5 metric tons in total, fully fueled. So let's try 7.5. Yeah, 7.25. That seems good. Cross that out, and then we can go into, we don't need that. We can use this, our launch code, and then we're going to do 405 plus however much is in here. So that's 405, 180 to get our fuel and our payload. And there we go. Now we're set up, ready to go. Because what I want to do, chat, is test and make sure in another operational scenario that we can do a manual boost back and then an automated landing. And then ideally, once that's there, we have our test set up to then create reusable recovery vehicles, I think. We'll see. So yeah, let's go ahead and save that. And let's go ahead and launch. And we should be good. Check staging real fast. Yeah. Yep, all good. Save, launch. And we'll go ahead and clear that other Minerva there. No problem. Hey, Audev, what's good? Hello from Twitch, that's right. And now I'm over here. But yeah, it's amazing to hear Snackless. That's really cool. Good on you, man. I'd love to get a vehicle that can get the booster like like your one small launcher, but it will lower it down and you'll drive off or get two helicopters. Yeah, I think we're gonna go with the recovery vehicle. I think we'll definitely go with a recovery vehicle style of system. Because yeah, essentially we can create what we have for our DCX, right? The truck that we would just make it really big. I mean, essentially we would probably make something like the gosh, what are they called? My gosh, why am I blinking? The shuttle transport vehicle. Not that. You know, the long boys. I'm totally blanking on the acronym for them. These things, right? The long boys, but that's actually the SPMTs. Is that right? Shuttle SPMT. I think that's right. Yeah, these guys. Yeah, see? They're used for like moving around gigantic mining equipment and gigantic power generation equipment. Oh, and also gigantic aircraft like the shuttle. Yeah, we're gonna probably make something kind of like this. Probably doesn't need to have fully actuating arms or wheels, but yeah, an SPMT is probably what we're going to implement in some way, shape, or form. And then we could basically have on our long boy a big transporter rector that can verticate, pick the booster up, and then land it, and then lay it down. I think that's what we might do. Might even come out positive from it. That's wild. That's pretty damn good. All right, so let's make this a test run here, chat. Get rid of all of that. Run this, see if it works. I actually don't know if this is going to work. I think this should work. Yeah, I think this should be fine. We'll see though. There we go. We have our camera view. But think about how cool those fully rotatable wheels could be. Yeah, I know, right? No kidding. Hey, and super hand with the launch button right on cue. Looking good. All right, vehicles away, pitching down range. Autonomous from here until Miko. Once we hit Miko, I'll take manual control just for the boost back burn. And then from there, we start up our landing script and have it land. Yeah, that's gonna be the goal here. You know, I also think I need to fix our. Do I actually have to fix our code here, or did I already fix it? Okay, we're good. So yeah, we'll see if we can't get the second stage into orbit as well. Actually, we won't because we'll have to do our boost back burn. It's fine. It's fine. We'll figure it out. Use FMRS so it auto lands and recovers for you. FMRS. Oh, flight manageable and reusable. Oh, that one. No. No. Cool. There we go. So essentially we can have that ghost ride on its way while this turns around. It starts its boost back burn. There we go. Had to figure out the right action group. Because essentially we want to do a boost back, but we also need to get our apoapsis above 70 if possible. Like that. Hopefully that'll be okay. Seems like a pretty decent landing spot if I do say so. Yeah, it seems good. 613 is about right on cue. And we can turn back to this before it goes away. Deploy, and we can get this into orbit now. At least that's the goal. 95 APO, that's pretty good. We're a minute away. Let's just lock it in right here. Cool. Demo mentioned if you have quick saves or revert or something off, you don't need to be above 70? Really? I have never heard that or tried that before. I mean, it's too late now, but like just in these options, so allow quick loading and allow reverting flights, turn those off and you can switch to a vessel at any point. I have to test that. That's interesting. All right. Huh. But do you have to be above 20 kilometers? Otherwise it would just delete, right? Oh, I just realized I'm not paying attention, chat. We are way over. I'm going to say that that's pretty much in orbit. So now what we can do is switch back. Has to be above 20, yeah. I figured, but that's pretty cool. Okay, then. All right, here we are. Starting our landing script. Yep, our trajectory should have us be just short of it, essentially. We'll see. See how it goes. Eventually, I also obviously want to automate the boost back. But I also kind of want to get back to... I feel like that is also going to require our own flight controller to make that work. But we'll see. I kind of want to get back to mission mode, though. And see if we can't start reusing these a little bit. I think that'd be pretty good to complete the loop there, even if we're manually boost backing. Boost backing? Is that a verb now, chat? I guess so. Okay, we're looking pretty good. So we are still commanding 250 meters per second towards the pad. We're now no longer. We're 2 kilometers downrange. We're traveling towards the pad at 95 meters per second. It's going to start correcting. Trying to mitigate our velocity as we get closer. Just like it's doing. Awesome. Yep, it's working as intended here. Trying to make sure it doesn't overshoot. There we go, looking good. Yeah, it's tracking that velocity really, really well. 200 meters from the pad in the XY plane. Okay, stand by. Coming up on our burn start here. About 5 seconds. 3. Oh, things are coming into view. 2, 1, burn. All right, tease it. I could just have it land at that point if I really wanted to. See, this is what I'm talking about, chat. The coupled pitch and yaw just does not work well for this vehicle. Anyways, going into landing mode. Skirt, skirt, no! Gotta be kidding me! Yeah, having that... Man. Yeah. Wait, also, it is going to 10, but our... that's interesting. Our altitude... Wait, what are we... Hold up. what are we printing out here? This is mode 4. So we're doing distance to pad, horizontal velocity, our commanded pitch, our vertical set point, and our altitude controller set point. I don't know if I care about the altitude control. Well, I do kind of care about that, but the vertical set point. The vertical set point is based on the altitude controller. The altitude controller needs way faster response. Holy cow. See, it's commanding -5 meters per second down, even though our velocity is much higher. It needs to have a much faster response. Okay. Finn served as a crush core, no doubt, no doubt. Who's back in for real, for real? Hey, what's up, Hellfish? Doing pretty good, man. Doing pretty good. Yeah, also, how we were commanding -10 degrees pitch, 15 degrees pitch. We were maxing out our pitch, but our yaw was lagging. Ooh. Oh. Ooh. Idea. Where is it? I have it. Called stopping time. Do I need to increase this? This would be control autopilot. There it is. Stopping time. Maximum amount of time that the vessel should need to come to a complete stop. This determines the maximum angular velocity. Defaults to 5. So is a faster one a larger number, or a slower one, or smaller? Which correlates to what? We could also actually just change the gains individually. Pitch PID gains, roll PID gains, and yaw PID gains. Then we should have auto tune off. Maybe that's what I need to do. Gains for the yaw controller. Let's change stopping time first, because that should kind of do it for us. The maximum amount of angular velocity of the vessel. So maybe I just need to have that higher when it's in that mode. Especially for the yaw controller, or the heading controller, I guess I should say. So yeah, let's do that. Put that here, and also change this. So let's try this to be like 1.2 and 1.2. Also, what does it matter? One for pitch, roll, and yaw. Pitch, roll, and yaw. Oh, yaw was 0.2? Wait. Wait just a second. That could be really bad if yaw is silly slow. Now see, that's what I have to figure out. Is a smaller number faster, or is a smaller number slower? Let's change that to 0.8 as well with that one. And then 1.2. Yeah, we'll just change it all to 1.2 to see how that goes. On here as well. Okay, that seems good. Kind of like a change in gain scheduling here. Okay, let's run that back then. Oh, I can't. Right. Silly me. And I forgot to autosave, didn't I? Well, technically, no, I didn't. But we can at least see how that goes. Not yet, Sneckless. Not yet. Yet being the keyword. Getting a good long vacation? Heck yeah, Matt Chad. That's awesome. That's really good. Okay. I'm really curious to see how the stopping time goes, because see, here's the thing. This is why I'm saying that I feel like we need to create our own entire control system, like flight controller from the ground up, because essentially what we have, right, is from the very simplest terms, we have a control system, which is our PID, right, which is getting some input and giving us some output based off of our error. That is, say, commanding our pitch angle. Well, this, instead of just being directly into our control surface, right, that's not the case. It's actually then going into our autopilot, which is basically a big black box, which I'm sure has its own PID loop and also then outputs to the control surface. So we're basically giving a pitch, our desired pitch angle, and then telling another controller to then get to that pitch angle instead of actually having our pitch angle be what our pitch angle should be, or you know, immediately transitioning from pitch angle to control surface deflection. So we're basically we have a middleman in the loop right now, and that's why I think tuning the autopilot, what we're using to then command the pitch, could be good. Like, that might be the issue here. Decreasing. Oh, so it's a smaller. Okay. Did I just not read that? Where are you reading that? So far, so good. Oh, they explain it on another page. Okay. Well, roll seems to be a lot faster. Is that just me? Is that a placebo effect? Ah, okay. Oh, it's in the tutorial. Okay. That seems way faster, actually. Look at it go. Oh, that's way faster, it seems. Question mark. Huh. Well, very jerky. Yeah. It can definitely be tuned, but I'm just saying, like, so bigger, I think, is better here. Question mark. Because that's what we did here. And I think that's also what I did up here. Where did I see that? Stopping. Yeah, I changed that to be 0.8 instead of 0.2. So yeah, let's change that to be 1 across the board. Bring that down just a little bit. But it did land. Kind of nicely, actually. We'll see. Like that could do it, actually. Oh, okay, names. That's a good call. Like, go, oh yeah, see, look at the roll control. See how the roll control is going a lot faster now? Yeah, okay. By all means, Hellfish, go for it. Yeah, what do they say in this thing? Is the maximum amount of time that the vessel should need to come to a complete stop. This limits the maximum angular velocity as a vector of 3. Okay. Computing the target angular velocity. Needed rotate the vessel towards the target direction is computed by summing a target angular speed for each pitch, roll, and yaw. If no roll angle is set, then the target angular velocity in the roll action is simply set to 0. The equation for this function, yep, that all tracks. I remembered this stuff. The reasoning and derivation, I don't really want to know the derivation. The gradient needs to be 0 for smooth function generation. Tuning the controllers, okay. I forgot to turn RCS on. That's my bad. Seems like we're okay though. It's definitely moving a lot faster than it was. Especially in the roll. It's very noticeable in the roll. Come on, go that way. It is jerky though. We could definitely smooth that out. For that time, at least we're getting more consistent. I mean, we're consistently inconsistent. No, we're consistently seeming to get closer now that it's able to actually go a little bit faster. So I'm getting a lathe, and a project I would like to make is a rocket engine cross section. Okay. Are there any tips you can give for profiling the inside of the model in an accurate way without getting into ITAR? Yeah, there's tons of open source resources if you're just looking to get like measurements that you can then like, you know, step into a lathe and whatnot. Because you're basically talking about having a cross section as in like from the side view. You essentially are going to look to make something like this, where we're looking at it from the side and you're going to see the cutouts of the chamber wall and everything, right? You're kind of talking about something like this. Yeah. Oh yeah, you can find tons of these things, I think, online. If you want to kind of calculate your own, it's an open source paper. Look up China Lake rocket paper. China Lake alumni. Did this one? Just to make sure everything is okay. Hunky dory. Nope, not that one. Not that it was bad. Just where is the? That's what it's called. China Lake. How to design, build, and test liquid rockets. Does this have everything? Oh, I think it does. Yeah, here you go. And if you go into design equations, it literally tells you like how to do everything, and then you can actually choose your own based on your own theoretical performance that you want, because it tells you step by step on what fuels you can use and what parameters you can use, and then based on that it gives you the length and width and you know, radius of the chamber and all that sort of stuff. So if you care, if this is something that you might be interested in. Otherwise, I'm sure you can find tons of open source schematics of old rocket designs and go off of that. I mean, if you just need like the dimensions, right? Like this one right here, you want something like that. But yeah, I think there's tons of stuff like that online. There's a lot of college papers as well that give you the dimensions and whatnot. Yeah. Rover I've worked way too hard on. Ooh, that's looking most excellent. Is this all stock? It looks stock. Yeah, it's stock. That looks quite nice. Very nice. Your stuff is always looking good. Whoops. Stop it. It is looking always good. Mm-hmm. Yeah, I like the way that you have the light set up, actually. Why? Why did you do that? All right, armadillo. Is this supposed to be an antenna, or what is that for? Emergency hop, anti-flip jacks. That makes sense. That makes sense. Yep, very nice. A little ramp for you. Oh, that's actually a really good design. Yeah, I like it. Pretty good. Man, that thing is beefy, though. Look at that, chat. That's one tiny Kerbal. You need a ladder to get into it. What do you... or to get on top of it. Beefy. Beefy, beefy. Boop. I like it. Some semi-active suspension. That's cool. That's cool. Yeah, my pleasure, Hellfish. My pleasure. Okay. So now this is our starting point. So the question is, chat, do I need to make things a little bit lighter then? Like 0.9, 0.9 maybe on this front? I feel like yaw might need to be like a lot more, because yaw seems to like really lag behind. And again, I don't know if that's like implementation from the autopilot, because for stopping time it should be pitch, roll, yaw. Okay, so pitch, roll, yaw. Yeah, so yaw should be last. So yaw should be last. Yeah, so we can try something like that. And you know what? I think I do want to add a potential rate limit. I don't know if I want to add a rate limit, actually. I really don't. I'll tell you what I do want to do is change the distance controller to be slightly larger. So that way it has a slightly more aggressive track to the pad. I think that would be nice, because we consistently seem to basically command only 2 meters per second, but when we're, 25 meters away, and it, roughly off by a magnitude of 10 when we're like really low, already going into our landing mode, right? Actually, where are we even at in mode 2? Because mode 2 is where this changes. Mode 2, we are 30 and we're tracking 2. So I feel like that needs to be a little bit more, right? We're basically 30 meters away from where we want to be, but we're only targeting approach of only 3 meters per second, not even. So yeah, let's increase that by just a tiny amount. Okay, let's run it back. Last one, and then we'll get back to our testing orbital vehicle, because I want to get another test article that has the docking ports on it, so that way we can start testing recovery operations. And then, like I said, that will bring us full loop, chat, full loop into fully reusable systems in game. Actually reusable, not pseudo reusable, not recoverable, reusable. All right, there we go. I have weakened servos as bogies, not quite a full rocker bogey, but it's enough. That's actually pretty cool, man. That is pretty good. I think one of my rover designs in the past just used pistons that were kind of like that, weak, right? But yeah, I like the idea of a servo for that. So that way you can... The only thing I wish I knew, chat, is why we're rolling left, but we're yawing. It seems like we're yawing right. But then when we get lower, it actually seems to be correct, where we are yawing left and then rolling left as well. Like, I don't know why up here it does this. It's something to do with the heading calculation, I guess. Like, I guess our heading, we're technically off of what we need to be, and so the roll is trying to correct for it, but I don't know. Weird. A little bit odd. A little bit strange. Side slip, that's the only thing I can think of. Is that our yaw error is actually off, and so we're rolling, but we're yawing, so it's like, yeah. Because then once we get down here, it actually does correct. Okay, there we go, tracking the pad. That's looking a lot smoother, actually. It's definitely active, but it looks a lot smoother. Oh, I spoke too soon. Now we're good. We're fine. Okay. Yep, still commanding a really high velocity. That's good. Yeah, see, now I don't know. The roll was a little bit off that time. Yeah, that one was definitely off. Not sure why. This would just be... It would just be good to eliminate the unsureness of the autopilot. Ooh, tippy toes, chat. Tippy toes. No. I don't know what to do, chat. I don't know what to do. Okay. We're good. Yeah, the leaning tower, of course. We're good. Anyways, let's go ahead and recover that, bring out our new version, and see how that goes. Give it a low taper fade, something like that. Something like that. That was some shady lean. Yeah, no kidding. We're good. Everything is fine, chat. Just it's fine. Totally safe. You have no idea, chat. It was totally fine. Totally within nominal operations. All right. Well, let's get out another one that's been updated with the docking ports. Let's fly it on another test trajectory, see if we can't land it. I'm going to F5 this time, and we're not going to worry about the upper stage. We know very well that the upper stage can make orbit, so that's fine. Oh, the other thing I do want to test is, like, if we do no reverts, well, so we can quick save, but we can't revert. Is that how that works? Because those are two separate options. Why are those two separate options, chat? Why can you allow reverts and then also disable quick saves? Because, like, what's the point of having quick saves if you can't revert? Like, shouldn't that just be coupled? It's an option. I think if I saw that correctly, I'm pretty sure that's an option, and those are two separate things, except they're basically the same thing. Anyways. All right, and this should have the docking ports. It does have the docking ports. Good for reusability. Cool. You know what I'm also going to need to do, chat, is actually change our upper stage connection point as well. If we want to actually reuse this, it needs to be a docking port, but that's beside the point. We'll do that later when it comes time. Let's go ahead and save that, launch it. Right up the rocks. Interesting Snackless. I like that. If you mess up, you got to go again. No checkpoints. KSP roguelike confirmed. Yeah, exactly. Yeah, let's see if if it loads up here. We'll go into the saves and see. not into the saves, into the menu. So if I go here into settings, right, and then we go into custom, allow reverting flights, allow quick roll. Oh, so those are, I guess, separate things. Because quick loading would be the F5, F9, but reverting flights means that you can pause and like revert, right? I guess that's what separation is. Just clicked for me. We're good. Never mind. All right, let's do this. Let's do that. Bring up our code, boop, boop, and launch. And then we're hands off, chat. Except we can get into a cool picture shot. Vehicles away. And roll program. Vehicles now pitching down range. Oh, really, Hellfish? Okay, okay. Nice. Very good, very good. Continuing to pitch down range. Stabilizing pitch for Miko. Getting ready for separation. And there we go. And we have good stage set. Meanwhile, we'll go ahead and start our boost back burn. I will try to get it above 70 like last time, so it's actually an adequate test. And then we go boop. And shut down. Seems pretty good, and we're above 70, so that's, I would say, pretty good. Okay. And we can coast on up. Yes, Hellfish, it does. Well, I wouldn't say automatically. I do have to program in the mass, but yeah, otherwise, yes. I have to basically say, hey, our mass is 4 kilograms, you know, 4 kilograms, 4 tons. And then it does the rest. There we go. See what I mean, chat? Did you see what just happened there? That's what I'm talking about with the autopilot. So I don't know if you guys just saw, but essentially the vehicle started off going, you know, in this orientation, right? We were going this direction, and we had our wings basically vertical, right? Kind of like pointing up and down, and this is our pad over here. So what it did initially was it swung the entire vehicle around in terms of its heading alignment, and then it managed its pitch. Actually, that's not even how we were, right? We actually started something more like this with our wings on the side here. So it then swung its pitch down, and then it swung its heading down, and then finally we rolled. So instead of doing all three at once, like I would like it to do, it essentially waited to do pitch, well, I should say pitch down, yaw left, and then roll. And so I think that's what's happening when we start getting into the control near the pad, and why it seems to lag so much on trying to actually move to the pad and slew over, is because it has to get the heading aligned and the pitch aligned, and the roll is off. So I don't know, it's a little bit strange, gotta say. Sounds like Starship, yeah, basically. So again, I would love to know if anybody has an intimate knowledge with how KRPC mod actually works, like in terms of the coding side. Because I know I've seen in chat at some point, a while ago, was one of the maintainers or authors of the mod. I would love to know how exactly autopilot works, and if there's a way to not have it try to decouple all the controls. Okay, tracking the pad. It's looking good. Trajectory's looking good, I should say. Okay, it is trying to match the velocity. Negative 38, 48, yep. It's coming in. 37, 32, looking good. Coming straight down on top of it. 21, 19. Stand by for ignition in about 3 seconds. 2, 1. Burn. Oh no. One of our landing gear locked. Okay, there we go. Whew. But see, then it wants to do this, and then it's like it can't right itself fast enough, which is really strange to me. Right on flame out. I mean, it's not bad. Like I said, we're consistently here from essentially an orbital class vehicle, which I'm pretty happy with, but I would love to know exactly what autopilot's doing in the background that just makes it seem to lag behind the actual desired control. But anyways, chat, we now have our very nice what do you want to call it, test article for recovery operations, because now we have this here and in a pretty good spot on flat terrain and everything. So now it's time to build a truck or some sort of SPMT that can come all the way out here, get up underneath it, put a transporter erector structure that can grapple these two docking ports, lay it on its side, and move it off. That's the next thing. But chat, that's going to have to happen laters, because I'm feeling it, chat. I'm feeling a long day of work, but I hope you guys enjoyed that. We are now moving into orbital class vehicles, and we're going to be staying here for a while. I'm going to try to probably in the next stream, which will probably be tomorrow, work on the recovery truck, see if we can't get that working, and if we can, great, and then we're back into mission mode, chat. Using the reusable vehicles to try and save money, because we need to hit 16.9 million per bucks. Actually, we need to hit more like at least 17 or 18, probably like 18 million Kerbucks, so we actually have money left over to continue doing missions, because we need 16.9 just to upgrade our tech tree, which is, it's a lot. But anyways, out, chat, I'm out. Hope you guys enjoy the stream. I hope you guys have a good Thursday, and if I don't see you, have a great Friday. Otherwise, we'll be back here playing more KSP.